Hey guys, welcome back to Total Tech. And if you're new to this channel, this is just a little channel that I do to give some tech tips, and hope you guys find useful. And if you guys are here, be sure to like and subscribe, share with your friends if you find this useful. We'd really appreciate it. So today we're going to talk about how to get started with machine learning in R. And if you guys don't know what R is, it's a statistical programming language that is designed for primarily data analysis, data analytics, and used by a lot of data scientists and academic researchers. But we talked about H2O in our previous video in this series, and we're going to talk about how to do H2O. The same thing we did, but this time using R. And the benefit of doing that is that we have a little bit more control on the data. We can manipulate it a little bit better, and also we can generate some pretty cool plots. So the first thing we're going to do, jumping right into it, is we're going to make sure that we have 64-bit Java installed. So right here on this Oracle JDK download page, I'm going to download the JDK 18.0. So I've already installed this, but make sure you download the 64-bit one and make sure you select the correct one for your operating system. I'm on Windows, but we really need the 64-bit for this to work because R has a little bit more constraints in what type of Java version we use. So to verify that you actually do that, you can open up your Windows terminal, and once the install has been done, you can type in java-version and just see if you have the right version. So right here, you can see that I have Java version 18.0 and that it is the 64-bit version. So that is good. That's what we want. Next thing I'm going to do is I'm going to go here and go to the cran.microsoft.com, and this is a mirror for downloading the Windows version of R. So the most latest version is R14.2.1, so I'm going to download that. I'm going to save that to my downloads, and once that is there, I'm going to execute it to install R. So R is basically a kind of programming language that's built on top of like the C language. So what I'm going to do is I'm going to download this and install it really fast. And okay, so it looks like I have an existing download and installed. That's fine. You can overwrite it. And let's just navigate to this C program files /R. So I'm going to open up here. Go to C/program files. I'm just going to show you where the download and install happens. I'm going to go to the R folder. As you can see here, I have an older version here that's 4.2.0. So the thing about R is that you can actually have multiple versions installed, and it'll default to the latest version, but if you ever run into issues like weird errors, stuff like that, it might be because you have an older version that's conflicting, so you can always remove the older version. So right here, R 4.2.1 is the latest version that we just installed. Looks like we're done, and if you go to the binaries and run r.exe, you can actually run R here, and this is, you can do things like create a new vector. So let's call this like my vector. And it's a vector of numbers, so 1, 4, like random numbers, right? And if you type my vector again, you can see the vector. So this is kind of like the old way of doing things in R, but this is really kind of tedious. It's all command line. There's no GUI, and we don't really want to do that. So what I'm going to do is we're going to go to RStudio here. So this is RStudio, and we're going to download the latest free version of here of R desktop. So I'll put all these links down in the description below, but we're going to download the Windows one for Windows 10 11. I'm on Windows 11, and we're going to run that. Going to do an install of this, and as that's installing, I'm going to kind of walk you through what we're going to do. So we're going to install R, open up R in RStudio, which is an IDE for R, and then once we do that, we're going to install the H2O package. We're going to install one more package called ggplot2, and that's like a very common like graphing package for R. Very useful, super awesome. You can make beautiful graphs with this package. And then we're going to spin up our H2O cluster and do our machine learning in R. So that's done. I'm going to run RStudio. Not Visual Studio. RStudio. There we go. And I'm going to open up this. And alright, so here we go. So this is, I have a script already loaded. So this is from before, but you can see that this is RStudio. This is the console that we just opened up. So everything we just saw in that terminal, that r.exe terminal, this is just all here in that console. So I can do the same thing here. But now we have this nifty thing here called the environment. So if I declare something here, so let's say my vector again, vector, and I create a vector of numbers, you'll see that it pops up here. And I can actually see the value, and every time I declare a new object or anything in R, it'll pop up in this environment. Additionally, there's this little thing on the bottom right where you can go to files, navigate through your file system. Any plots that you generate will show up here, and you can also see what packages you have installed. So the first thing we're going to do is install H2O. So if I go to the H2O website and go to downloading and installing H2O, go to install R, and installing an H2O's package, we're going to copy these ones. So we're going to copy this one and paste it into our R script, so we can create a new R script here. So if I create a new R script, I can go new R script. So I already have one here. So I have these 3 commands already here. So I'm going to first run this, and this is going to make sure that the packages are up to date. And then I'm going to run the next command, which I already have there, but I'm going to show you guys what I would do in this case. And I would paste it here, save it, and then just highlight it and run it. So that'll install the dependency packages, which is R curl and JSONLite. And then finally, I'm going to install our H2O package. So that's what this command does. And this is going to install the latest stable release of H2O for R. So as that's going, I'm going to explain to you why we're doing it this way. And typically the way you would do it is you would probably go to Tools and Install Packages. And this goes to the Cran repository, and you can search for H2O here. But typically this is not the most up-to-date version. It's probably a couple versions back. So we always want to do it the way they have on documentation on the website, because it is the latest stable release. So what that's going to do is that's going to install a bunch of packages. And as that's going, we're going to actually wait for this to install. It's going to install the latest version of H2O. And remember, you need to have Java enabled also. And we're going to install one more package while it's going to. So we're going to we're not going to update packages. We're going to install one more package. So we're going to install the ggplot2 package, and we're going to install that as well. So as this is all going, I'll kind of run you through the next steps. So what we're going to do next is we're going to declare the libraries. So for every R script, you have to first declare which libraries you're using in your script. So we're going to declare library H2O, which is the one we're installing now, and library ggplot2, which we're also installing now. So we need to declare both those libraries, and then we're going to spin up a cluster. So this cluster is going to be called local.h2o equals h2o.init, and I have 16 gigs of memory on my machine, so I'm going to use 10 gigs of that, and I have 16 threads, because 8 cores, 2 threads per core. So I'm only use 10 threads, because I don't want to use all 16 threads. If I do that, then I'm going to basically clog up my entire system, and everything's going to crash. So we don't want to do that. So be very careful when you're initiating this. And if you don't declare these, they're not necessary to be declared. H2O, I think, defaults to half of your system memory and half of your system threads, so you'll never accidentally by default use all your memory and all your threads. Okay, so we're going to do that. So let me run these two. Okay, so running that. Oh, okay, looks like we're getting an error installing. So let me try to install H2O again. Let's run this install package one more time. Yeah, it might have been the issue that I tried to install both at the same time, so you might have to do one at a time. Sometimes it doesn't like it when you try to install multiple packages in parallel. So the safest thing to do is actually just install one, then install the other, and that's the best way to do it. So I tried to install both at the same time, so that's probably why we ran into the issue. So we're just going to wait as this downloads again. H2O is a pretty big package because it has all these machine learning algorithms, so it'll take some time. But if you have fast enough internet, it won't take too long. And hopefully your system is kind of a more modern system, but even if not, you'll be totally fine. And so we're going to run this local H2O, and then we're going to also run a demo just to show you that it works. And this looks like we're halfway. And the other thing that we can do is once we run this cluster, we can actually open it up in a new browser. So we can go to localhost 54321. So I'm not going to go there yet, but you can see that I've already gone here before its previous H2O flow, but that'll run up the cluster. You can actually interact with the cluster through the browser as well. So okay, looks like we are still installing. Hopefully it is going to work. Lazy installation. Installing indexes. Almost there. Moving to final location failed. Interesting. Looks like I might have an existing item here that might be conflicting. So let me go resolve that really fast. Let's go to that location and see if we have an existing file. 4.2. Looks like there's H2O lock java.jar. Okay, 7.4. So let me so if I run this, is there still an error? That's the question. Yes, there is. So let me delete that folder. So sometimes you get some weird things that happen here. So let me delete this folder. Being used by another program. Interesting. Let's close this and then delete it. More details. Can I see which program is using? Let's see. Dun 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 dun. Where is H2O? Okay, looks like there's a Java system running, so I'm going to kill that one. And then I'm going to delete this. Yeah, there we go. Okay, so it looks like I had, oh, okay, no, that's not working, huh? Interesting. Let's see, is it running on a background system? Is there an app running that is using H2O? Let's try this again. RStudio. It's always fun troubleshooting stuff on the fly while you're making a video, right? Okay, H2O package is required but not installed. Interesting. Okay, let's install again. Let's see if that works. See if you can go to that location again, see if those packages are still there. Okay, it looks like H2O did delete, so I think we should be okay now. Yeah, so I think what happened, let me just explain to you what I think happened here. So before I made this video, I was running a test to make sure that all this is working. So what happens is when you run H2O from R, it spins up a Java cluster in the background. So if you exit R incorrectly, it's possible that that Java cluster was still in the background and it was still running the H2O cluster. So when you try to initiate a new cluster, it always checks your system to see if there's a cluster that exists. So it saw that old cluster and was basically confused. It was like, hey, like you have a cluster that is already going. But because I had incorrectly probably terminated my R session, that cluster was not associated with an R session anymore, so it was kind of just floating in system memory. So I guess you have to be kind of careful with that. Yeah, so it looks like it installed correctly this time. So now if I do library.h2o, yeah, now we're good. So now I've done that and I can load the libraries. So if you run into that issue, you can do what I did and kind of just search your task manager and make sure you don't have any like floating Java processes running, because Java has a tendency to do things like that, and I've just worked with Java a lot, so I kind of had a feeling that I knew what the issue was. But that's how the troubleshooting works. So now if I run this local host, I'll spin up a new cluster because that old cluster that was floating around that was not associated with an R session is now terminated. And so now it's starting an R session, and we've run an H2O cluster, and you can see this cluster in the environment here. It has an IP here, localhost 54321. So if I go here to my browser and just go to that, you can see that we have H2O spun up here and we're good to go. And we can start importing data, we can start running models. You know, I can run a gradient boosted machine or a distributed random forest or deep learning model. So that's great and all, and then we can run this demo and it'll basically start the demo, and we're going to run a k-means cluster of some prostate cancer data. So it downloaded some data from H2O that's like automatically as a demo, and you can see this data. You can open up this data and actually see the data of the information. So you can see the PSA ratio, the Gleason index, and then also information about the individual and their demographics, like medical information. So that's pretty cool, and we create a k-means cluster for 10. So that's awesome. So now how do we do this for data that we want? So if you remember, I'm going to walk through the iris dataset again, which is the machine learning dataset. If you don't remember that, you can refer to my previous videos. And this is a UCI machine learning dataset, and we're going to load the dataset in. So we're going to run iris dataset. And so this is the dataset that we're working with. You know, it has what type of iris we have, and it has 4 different columns, which is sepal length, sepal width, petal length, and petal width. So we're going to use this, and then I'm going to create an index here to do a random split of 0.8 to 0.2. And basically all this is doing is randomly picking 80% of the indexes, and then we're going to put 80% of the data into a training data set and 20% into a validation data set. So now we have train here. You can see there's data here, and then validate here, and this is our training data set and our validation data set. Now the thing about R is that it has very specific types of kind of object types. So what we have to do is we have to make sure that the response column, which is the flower column, that we put this back in as a factor. So what I'm going to do is I'm going to do train flower column as dot factor train flower, and I'm going to do the same thing with validate. So this just makes sure that we're that the format of the data is correct before we put it into H2O. And now we're going to load the data set as hex data frames into H2O, and to do that is as.h2o train destination frame and equals the name of the destination frame. And then in R itself, we can call it the same as the destination frame. So I'm going to do that, and so you can see here that it loaded the destination frame as train.hex and validated hex, and it successfully loaded into H2O. And we can actually validate this. So let's go to the web browser. Let's go to data. Let's list all frames. And you can see here that we have that prostate sample data set that was from the demo, and we have our hex train for validate and hex train for hexes for train and validate. So these are data frames. You can actually view the data and see that the data is actually imported correctly. So that's great. And then now we're going to actually create a couple other variables. So we're going to make sure that our response is flower. So this is the flower column. This is the name of the column. And then for predictors, we're going to get all the column names that are not the flower column. So that will be the sepal width, sepal length, petal length, and petal width. You could also just manually type this out, but this is actually the more efficient way to do it with these commands. So this is predictors that are not predictors in response, which is response here. And if you have a lot of columns, this is way more efficient than manually typing out every single column. So I would highly recommend doing it this way. And then we're going to create an AutoML model. So to do that in R, we're going to call this model, and this is h2o.automl, and then x is going to be our predictors, which we just created, and y is going to be our response. We're going to put in a training frame, a validation frame, and I'm going to do a max runtime of 60 seconds. Again, the default is 1 hour, so if you want to sit there waiting for an hour, you can do that. You might get some better results, you might not. There's always a trade-off with how you do that. So we're going to do that, and we're going to run this model really fast. And then after that, we're going to grab the leader model. And if there's an AUC, you can grab the AUC, but I think sometimes, depending on the data set, you won't actually get an AUC. So you can see here that we're running the model. You can watch that. And right here you see AutoML XGBoost is not available. This is because I don't have a compatible GPU for XGBoost. So I think for XGBoost you need to have an NVIDIA graphics card. I have an AMD graphics card, and you also need to have the CUDA software installed, which I do not have installed, obviously, because I have AMD. So if you want to use XGBoost, which is kind of like a super powered version of a gradient boosting machine, you do need to have a correct GPU and also have the correct drivers installed. So as that's going, we'll see we're at 71%. You can also see this happening in real time on the okay, we can't do this because it's still training, so we can't look at this because it's like, hey, you can't look at the models because they're not complete yet. But once the models are complete, we can list all the models and see which ones were created. Okay, so it looks like we're done now, so maybe I should be able to do it now. Models, list models. Yeah, there we go. So these are all the models that were trained, and we can see, let's see, let's grab the leader and see which one that is. So let's grab the leader, and now we can look at the leader model, which is here. And it looks like our leader model is a gradient boosted machine model, grade 1 AutoML model 12. So let's look at that. Grid model GBN 12. So it looks like it's this one right here. So let's open that one. So you can see the scoring history, the log loss here, and you can see that the variable importance is, and you can actually see the precision recall. And it's pretty good. Like the training is like 1.0, which for training that doesn't really matter, but because you're always going to train pretty well on your training set. But the validation one is actually pretty good too. We're getting 1.0 in some of them, and then 0.75 in a couple of them, precision recall. So not like perfect, but still pretty good. So the cross validation metrics are still very high, above 0.9, which is what we want. And the cool thing is that in R, you can see here that you can actually see all the other things here. You can see like the parameters. So, you know, n-folds, cross validation. You can see the number of trees, the max depth, the minimum number of rows, stopping tolerances. You can also see other parameters. And yeah, so that's all very useful information here. So now, what do we want to do with our model now that we're done? Well, actually, we want to generate plots. And you know, if you do everything through the UI here, the UI, you can get this plot, and that's pretty much it. That's like the only plot you can get. But if you want to get like very special plots, You have to do things either through like kind of through scripting. So that's why that's where R comes in. It's very useful. So what we're going to do is we're going to create an explainability plot. So this is going to be h2o.explain our model validate.hex, and we're going to run that, and it's going to create an explainability plot. And then after that, we're going to do h2o explain all of these, and we're going to create a bunch of plots. And once that's done, we're going to generate a bunch of plots here that are very useful, and I'll kind of walk you through a couple of them. But you can see here a partial dependence plot, and you can see that it's for specific values, and you can also see a model correlation here. So this is a heat map of like which models are more correlated with each other. And you can also see a variable importance here, so you can see that petal width and petal length are the most important for the models to successfully work. So yeah, this is a quick crash course. Hopefully you guys found it useful. If you do, like and subscribe, and yeah, thank you for your time.